A 60 Hz voltage or 240 effective value is impressed on an inductance of 0.326 ohm. Write the time equation for voltage and the resulting current. The second question says find the maximum energy stored in the inductance. First, I'd like to look for equation for voltage. Equation for voltage, which is equals to V equals to Vm sine Wt. Now Vm is equals to root 2 times Vrms. That's voltage of the root mean square. Our root mean square is equals to Vm times 1 over root 2. But now we're looking for Vm. We have given us our voltage for our root mean square. So what's the voltage? To be 240 volts. 240 volts. So our V root mean square voltage is 240 volts. So now I got root 2 times 240 to be my maximum voltage. So Vm, we multiply with 2 times 240, we have 339.41. So from there, we will now take it to be, this is our Vm, we'll look for it. This is the voltage of the resulting current, of the equation of the voltage. This is the equation of voltage. Now we're going to find for sine, we have W. We're going to look for what is W. W is wavelength, and wavelength is 2 pi f, the formula for it, where 2 stands for 2 times pi 22 over 7 times frequency. Now frequency is what? Is 60 Hz. So I'm going to say times 60. So from there, this will give us 337 or 377 rather. 377 Hz. So to give us 377 Hz per second. Okay. Now if I should write for voltage, the time equation for voltage is obeying Vm, which is 339.41, then sine instead of W, we have 377, then T. Okay. Now what about for current? Now for current, I is equals to Im sine Wt minus pi over 2. Magnetizing current here, we don't know. And magnetizing current is equals to maximum voltage over, it can be over R, it can be over SL, it can be over SC. So let's see what they gave to us. They gave us inductance, which is what 0.2. This is going to be divided by what? Divided by XC. Now what is SC? What is SL rather, not SC? SL. What's SL? SL is inductive reactance. And inductive reactance is measured in ohms. That is why it's here instead of resistance. So now, the question never gave us inductive resistance, rather it gave us inductance. So how do we now find inductive reactance? From the formula, SL is equals to 2 pi FL. giving us WL, wavelength times L, that is SL, okay, 2 pi F times L. And this will be 2 times 3.142 times 60 times our inductance is what? 0.3326. Okay, then when you multiply this, what are you going to have? This is equals to 122.9 ohms. So I'm going to equate it back to this. We have Im to be equals to, so our V mass now is 339.41 divided by our SL. So divide this, what do you have? So it's going to give us 2.76 ampere. So when resulting current for the time equation is equals to Im sin Wt minus pi over 2. Our Im now is 2.76 sin W is 377 minus our pi here will be taking 180 divided by 2. 2.76 sin t minus 90 degree. Final answer. Now the energy stored is equals to half. Since we are dealing with inductance, we call Li square. Assuming we are dealing with capacitance, we have half CV square. But since it is not in capacitance, but in inductance, we have it to be Li square. So Li square. So now we're going to give us half times our inductance is 0.326 times our current, which is 2.76 square. So our final answer is equals to, so this is going to be equals to 1.24 joule. Final answer. Like and subscribe if you like this video. Two coils A and B connected in series across the 240 volt 60 Hz supply. The resistance of coil A is 5 ohm and the inductance of coil B is 0.015 ohms. If the input supply power are 3 kilowatts and 2 kilovolt ampere resistance, determine number 1 the inductance of coil A and the resistance of B, the voltage across each coil. Now we're going to find first inductance of coil A and resistance of coil B. But first, let's draw the circuit. We have a circuit diagram like this. No. Or something like this. Okay. So move it like this. Okay. Move like okay. So we have that from there.
Okay. And I will shoot the video.
Right. Help our guys, man. Over.
Mommy to cook like
You need to do what?
noodles and chicken.
No.
And
Could you end up?
Egg and fish. It's bomb.
I think it again.